Okay. There is electronic simulation software that you can purchase that will simplify the Boolean expressions for you without you having to do all the work that we've been doing. But the Karnoff's maps is the easiest way for you to reduce it. Even if you purchased a software like this and had it for yourself, I would not let you use it on the test. So you might as well learn how to do Karnoff's maps. They do say that NI Multisim is a really good program for reducing these equations. They go through telling you exactly how to do this. And I don't think this is on our disk. But I'm going to go back and look. But I could not find any logic converter anywhere. Okay, this tells you basically how to run the logic converter software, which we do not have, and I have not been able to find it with their supplied disk. If you see it, let me know. I don't know. Okay, so we're going to look at creating PLC ladder logic diagrams from logic gate circuits. You did some of these in your homework, but I didn't exactly cover how to do it on purpose because I wanted you to try it so that you could see kind of that it's not as easy as just doing it. Sometimes when you watch me do it, y'all have to realize I've been doing this for over 20 years. So I know this. You have not. So when I make it look easy, sometimes you don't pay attention. So I thought if I gave you the homework, let you try it and make mistakes, then you would pay more attention today. That's why I cut this into half. So we're going to look at converting each gate to its equivalent ladder logic circuit. So let's look at one of the homework questions. I'll tell you what, let's do the easy one. I know everybody did the first page. Most of you were bringing them up to me, so let's do the second page. It's basically the same thing. You didn't have the easy one, is that what you said? All right, our first one had two. Actually, I'm going to change slides. Do a nice clean one. We had two AND gates. Which feeds to an OR gate. And I think that's supposed to be A for alarm. So this would be after hours. The front door is open. Or after hours. And the vault is open. The easiest way to do these, guys, is start with the end. Alright, so I'm going to show you the easy way that I think is easy, and then you're going to have to work enough of them that you come up with a way that's easy for you. A lot of the ways that I teach how to do some of these things are ways that I figured out when I was sitting in your seat out there. I worked enough of them, I figured out what worked for me. Sometimes my way works great for you guys. Sometimes it doesn't. So if you don't like my way, find a new one. Just make sure you get the right answer. Okay. So what kind of gate, starting with the A, so we know that we're going to have an output called A. Everybody okay? What kind of gate is this? OR. So what is our Boolean symbol for an OR? What kind of mathematical symbol does OR represent? Addition. What kind of circuit does OR represent? Parallel. So that tells me I got a OR gate with two legs. That tells me at some point down here I'm going to have two parallels. I don't know what's in them yet, but I'm going to have two parallels. Now I may have to erase this because I guess I shouldn't have drawn the front part. I didn't leave myself enough room. But I have two parallels now. All right, so what does each one of these parallel legs go to? So let's look at just the top one. So what is the top rung of my parallel going to be? What is this symbol? What is the mathematical representation? All right, so times, and how do I connect things on that? Series. Write your notes or don't write your notes. I'm doing it because I want you to see how we're doing this. So looking at this series, how many inputs am I going to have series? Okay, I'm going to have two inputs series. Y'all see that it has two legs. So that tells me I need two inputs on the top rung of this series. Now, are they normally open or normally closed? Do you see any inverters? So they're normally open, and this will be H and F. So that's leg one. Let's go back to the OR. Let's figure out what we need on the next branch of parallel. What kind of gate is this? What is the mathematical representation? How do we connect them? So I have two more in series. This one is going to be H and V.
I didn't make it a branch, I just brought it back to line one.
Same thing. Electrically, it's the same point. You could have drawn it like I did, like that, or you could have drawn it back here. So that was his question. Either one of those are correct.
How do you know if it's open or closed? What they call it?
Do you see an inverter? An inverter is a triangle with a bubble. That bubble right there means negation. It means that you invert it. So if you see none of the bubbles, then everything is normally open. Now we do have two H's in there, right? Which we would not normally have to do. They could be combined into one, which is actually the next step down here. I just did not want you to do that. I didn't want you to do that because I was trying to get you to draw it just like we see it. So the next one is an AND gate with an H. Oops. Same circuit, only simplified. Sorry, this is not real easy to do. Let's scramble it moving. Okay, this is the same circuit, only simplified. Instead of having 3 gates, I now have 2. We're going to do the same thing, starting with A. Type of gate, this one right here. AND gate. Mathematical times. How do we connect to an AND gate or with an AND gate? Series. So in this one, I'm going to start with series. This says coming off of this AND gate, I have how many series contacts? 2. One of these, so this is H right here. I could have made either one of them H. So it doesn't matter what order. But I just made it the front one. Okay, so H is right here. Now coming up right here, this group right here, if you notice it comes down into an OR gate. What does OR mean? Add and parallel. So that tells me that I have how many branches parallel? 2. I've already got one of them drawn in here, so I know I got to have one more. So make this one F, make this one V, and that's that one. It is much easier, though, if you start at the end. I need another sheet. I guess we'll erase this one. All right, everybody okay so far? Let's look at this last gate that you had. If that's what you want to call it. Okay, so this is the last circuit that you had to do, right? Well, the last gate, oh no, I'm sorry, there is another one. Oh, good. Oh, I didn't do the most complicated one, but that's okay. Well, I'm gonna leave you a few to play around with. So we have a motor. Coming off of the motor, what do we have? OR, which means addition, which means parallel. How many parallels do I have? Alright, so I have 2 parallels. On the first one, let's just go up and run the first line here. On this first one, what's attached to it? And. So that means what? Multiplication in series. So, how many legs do I have on the front? 2. So I have two inputs in that branch. So we call these PBR and SWB. Next leg. I have a what? An AND series, right? I'll explain in just a second why we're doing the ANDs every time. I mean the multiplication every time. How many legs do I have coming off of it? 2. So this one is TSW. Oops. This one goes to an OR gate. What do I do with an OR gate? Parallel. 2 legs off that parallel, right? Off that gate. This is LS and this is PBG. You see how we did that? Is it easier going from the end? What if you had to write the Boolean expression for this thing? No, you would not. I wouldn't let you. If we do what we were just doing and you come in here each time and you put the symbols in here, which is what I did a while ago, it makes it much easier when you're writing the Boolean equation. So if I were going to write the Boolean equation for this one, it would be PBR times SWB, right? And I might group those just so that I know that's on that one AND gate. Just keep up with it for myself. Then that is ORed plus with, and I got to drop down on my line, I'm sorry. LS plus PBG, and then that is times, that whole thing is times TSW. And that's how you do it. You basically do it the exact same way you do this down here at the bottom. If you come off of it, you know you're going to have a plus, right? You have 2 variables on that plus. Well, that's why I put them in parentheses. Okay? So creating PLC ladder logic diagrams from the Boolean expression. Did I have you do any of those for homework? I don't know that I did. Let's look at, okay, let's look at not Y plus B plus CD plus EB. I need another slide. Okay, so let's try Y equals not A plus B plus CD plus EB. What is the main theme? How are all of those connected? Plus. Do you see that? Each one of those are connected with a plus. How many variables do you have? How many groups do you have that are plussed together? 4. So what is a plus? What symbol is a plus? An or? Sorry, I forgot to turn my pen back on. So we have an OR gate. What is the rule for an OR gate? How many legs must an OR gate have? At least 2. So I have 4 variables. Can I make a 4-leg OR gate? Why not? They make them. When you go buy an OR gate, it's in a chip, and you can buy the ones that have 2 legs or 4 legs or 8 legs. I think there's even one that has 16. So we're going to use a 4-leg. 1, 2, 3, 4. I may have to move these out, but that's what I'm doing for now. Okay, so on this first leg, I have not A. On the second leg, I have B. On the third leg, I have CD. On the last leg, I have EB. But those variables are not finished. You understand what I mean by not finished? They're grouped or they have something else with them. The only one that's actually finished is the second one, B, because it is one variable and it's a switch. It's a B. A is not finished because it's not. How do we get a normally closed? Or how do we get a not? An inverter or not gate, right? So there's my inverter. Now I'm back to A. So I can put an A signal in. Gets inverted. B just comes straight back. CD, what does that mean? C and D, which means I've multiplied it, right? But C and D work. So that is what kind of gate? If it's ANDed, that's pretty obvious, isn't it? So now I can take the C and D that was here. Now I have a C and a D. Okay, so far. The next one, what do I have? An AND. What's on the end? You got it, that's why I made it longer. But I can't have two B's on here, so guess what I gotta do? Just tie it back up to that guy. So I have back to my 5 variables. A, B, C, D, E. Just B's in there twice. Alright, questions? So start with the big thing. I guess I should have put, actually at the end of it, I should have put Y. But,
I have a question.
okay.
With, 9A, with the info, so that actually saying before we get to the info, even if it's open, I want to get past the info.
Well, no, it's saying that I'm gonna put a signal in for A. So if I put a signal in, it gets inverted.
Yeah, it gets the first, it's signal come in as it's open.
No, signals don't come in as open.
It gets come in as a signal.
You're getting two things confused. This says if I do nothing at the front.
Yeah.
Okay. If I do nothing, it's got a 0 here. So it has a 1 here, and this is activated. All right. If I leave it the way it was, then when I put a signal on it, it goes through. Right now, if I put the inverter now though, and I reach up and push it, I turn it off, not on. It's just reversing what you put on it. You're thinking normally opens and normally closed, a normally open before and a normally closed after, and that's not the case. It's just saying what my function is as far as what I do. So this one says if I push it, it turns it off. If I leave it alone, it stays on. Y'all okay?
I have a question. You've already got B, which will give you a signal. Why not even put EB in there?
You wouldn't necessarily have to. It's got 5 variables, and I'd have to have a 3D chart for Carnot. Oh, you want to put that one in ladder logic? Okay. We have a Y. Coming off of the Y, what do we have? And how many branches do we have? 1, 2, 3, 4. I may not have left myself enough room, but maybe I did. So on the first one, leg 1, what do I have? Not A. On the second rung, what do I have? Normally open B. On the third rung, what do I have? And actually, you can actually look right here next to the gate. I have C times D, so how do I do that? Series. All right, last line is can be in this part twice. You just make sure if you're actually doing this PLC, you make sure that you address both B's exactly the same. So if B was I11, then the next one would have to be I-11.
When you just anything, you drop that Y between, goes to,
In the bottom down here,
yeah, somewhere.
as long as you just put it at one place. But you cannot put Y in there more than once.
Yeah.
An output can't be used but once, so we have to tie everything into that one output. It looks better if you leave it at the top and put all your inputs down below. And the only reason I'm telling you that is because this is the only way the PLC will let you put it in the diagram. So if you were actually going to go up there and program this, it will put the Y up top like that. So you really need to get kind of used to looking at it that way. Questions? Okay, we did one, so we don't necessarily need all that instruction. And we just did this basically because we took that same gate and we actually did this. Isn't that exactly what we came up with? Not A, B, or CD, or EB.
Question kind of like that, maybe just left, what when you put in a bracket, you're coming out the top rung,
Uh-huh.
and then when you come out with the feed, the L2, you know, the main line, it doesn't matter which one you feed from, as long as, you know.
You mean because I started at the left side as opposed, I mean, the right side as opposed to the left?
I tried in the run in one place, we tried in 4 places, does that matter? The left run, L2 run, I mean, the L2.
No, they did it like this because the PLC logic shifts it like this.
But it doesn't matter. Okay.
And when you're drawing it, a lot of times in relay logic, which is actually where I learned most of this, in relay logic they tie everything back to line 1 like we did. So you just draw a straight line on both sides and that's the way you draw it. But you also have to think in relay logic, you don't have a computer drawing this for you, you're drawing it out longhand. But the progression here of this line, oh. Of this line right here moving down each time is because of the program. And that's what you're asking, right? About the thing going in. Last one we're going to look at is converting logic gate circuits to ladder logic. Sometimes it's easier to find the Boolean expression. So this is the circuit they're going to give us. So we have A, or not B. Now let's see, A and B or CD and C. And see, I would draw this out a little better, but the best way to do this is exactly what they're saying. Go ahead and write the Boolean expression. So you're going to take A at the front, right? It is in series with a B, and it is a not. I don't know if y'all can see that. Okay. And then it is parallel with C, D, right? And all of that is now series with C. That goes into a control relay. Now, where do we put the control relay in our Boolean expression? We do not. All the control relay is trying to tell us, look at the next line. What did they do with the control relay? It's a normally closed, so what did they tell us that did? How do I get a normally closed? I inverted it, but it was inverted. Everything that's on that top line gets inverted. Y'all see that? Yes or no? Everybody sees that it's a normally closed, so it said to invert all of it, because everything that's attached to control relay gets inverted. And actually, that should have been a not C, not a. Okay? And then all of this, we have to add the A. So all of this gets multiplied to A. Now, if I were drawing this, I would draw it in a logic gate circuit. I wish they'd keep that on the board and have the other. I would draw this on the logic gate circuit exactly as it has it with the control relay, and I'll show you what I mean. If I'm doing the gates, I'm going to look at this top line, okay? And we'll get to where the control relay is. So, just like I would do with an output, I'm going to, well, actually, this is irritating me. I'm going to do the bottom rung. What did I tell y'all to do? Start at the bottom, right? So here's my Y. What's attached to Y? Well, it's going to be that control relay, okay, but we don't want to do that yet. Oh, wait a minute, I'm not doing PLC logic, sorry. I'm supposed to be doing, we're supposed to be doing logic gates. So, looking at this logic gate, if we were trying to find this, on Y, how are these two things, only A and control relay, that's all I care about. How are they connected? Series. So what kind of gate is that? How many inputs does my AND gate have? 2. I have 1 for control relay and 1 for A. Are we okay with that? Yes. All right, so here's A. The top one is a normally closed, so it gets an inverter. Yes. So this inverter right here is the control relay. With me? So now let's start here. How are these three things connected? Series. How many series do I have? 3. So I have an AND gate, right? 3 legs. 1, 2, 3. I'm kind of going to swap this around just because I want something in a position. But one of the legs is what? Inverted C, well, it's a not C, right? So what do I need to do to get this to a C? So that got finished. You see that? Okay. What about the second leg? I got something going on with that one because I got more than one. It's more than one variable, right? So I've got to do something else to it. So how are the two groups connected? In parallel, which is an OR gate. Whoever said that. On the OR gate, I got 2 legs, right? Because I got 2 branches. One of them has a not B, right? The other one has a C and a D. I'm kind of running out of room here. So I've got, for the B, I've got to put an inverter, right? To get it back to B. The C and D is still grouped, and how are they put together? What's my last leg down here? Do I have to do anything to that A? No, but the problem is I got an A right here. And I got an A right here. So I probably do. Now there's only one C, isn't there? Oh, I'm sorry, there's 3. You're correct. I'd tie my C's together. Now, if you forget tying those together on the test, am I going to count off points? No. But I'm going to mark it and say it's 2 or the same. So the same thing goes. Start at the end and work backwards. They tell you to do the logic gate circuit, do the Boolean expression first in the book. I don't know that helps. My opinion. I can do it from this drawing easier than I can in person and figure out what to do with that long line. There is one other thing that I want to mention. Go back just a second. There is one other thing that I want to mention. It's actually a Boolean rule. A Boolean algebra rule. I was kind of hoping one of these would have it on there, but it does not. If you have something like So if you have something like this, not A, not B, C, not D, all inverted. There's a rule that says you can break the line, change the sign. Break the line, change the sign. That is a rule. Okay, so what that means is, because I have a long line up there, I can come in here and break that line on each one of these variables. But when I do, it has to change from the multiplication sign to the addition. We only have two signs we use, right? So if it's not multiplication, it's got to be addition. So each one of these are multiplied together, correct? So if I break that line, I have to change that to a plus. So now I have two short lines plus. Two short lines plus. When I get here, I have one line and two lines here. So if you invert something twice, you go back to its original form, right? If I start that direction and I turn around, I'm going backwards. If I turn around again, I'm going the same way I started, right? Okay. So what we've got here is not A. Two negatives make B is what? No, it's a not B. So that makes it a B. C only has one line over it. Makes it a not C. Yes. And then I got a not B, so that makes, a not D, so that makes it a D. So this equation right here is the same as that equation. But to me, the part one we just changed it to is easier to deal with. I got rid of a lot of gates. I think in your lab book they have one of these where they have the long line across and several little lines. Just be very careful that everywhere you break the line, you change that sign. Because you can come up with something very different. Good? Questions? That's the end of this chapter, guys.